Okay, so we are here with another episode, and in this episode, we are going to be covering a question that is very different from all the other questions that we covered throughout these past few weeks. And why do I say that there's a slight difference between this question and the question that we've been covering through the past few weeks? Is the fact that the theorems that we're going to draw our focus on is going to be the theorem of line from center to midpoint of chord, and this is a theorem that a lot of students do forget about. They pay no attention to it, and it goes unnoticed amongst grade 11 and grade 12 students. And this question heavily centers and is heavily dependent on this theorem. Okay, so what I want you guys to do is I want you to pay very, very close attention, and if you enjoyed this video, be sure to subscribe. Okay, now let's get started. 8.2. In the circle below, we put center O. DE equals to EF, which equals to 12, FH equals to 25, OG is perpendicular to FH, OE equals to 5, and OG equals to X. So before we get started, we have to we have to take note of all the theorems that apply to a center. Now, we have to identify our radius line, we have to identify diameter, we have to see if line from center to perpendicular chord is applicable. We have to see if line from center to midpoint of chord is applicable. This was angle at center twice as much as angle circumference, by the way. And then line from center twice as much. No, sorry, line from center to midpoint of chord. So we're going to start off with the radius. A radius is a line that stems from the center and touches the circumference of a circle. So OD is a great example of a radius. OE is not a radius. OE is not a radius because it doesn't extend all the way to the circumference of the circle. OG similarly is also not a radius because it doesn't extend all the way to the circumference of the circle. Okay, so the only radius that we were successful in identifying would be OD. OD is the only radius. Now, what about a diameter? A diameter is a line that crosses through the center of the circle, resulting in the diameter touching both ends of the circumference of the circle. And this is something that does not appear to be in this question. Okay, we can clearly see that we do not have a diameter in this question. We just have OD, which is a radius, OG, which is just a random line from the center, and then we also have OE, which is also just a line from the center. So we definitely know radius angle at center twice as much as angle circumference. Now, this theorem is also not applicable because in order for this theorem to be applicable, we would need lines. The center would need to be subtended by an arc, and the only way it can be subtended by an arc is if we have lines that stem from the center and touch the circumference of the circle. In this case, the only line that stems from the center and touches maybe the circumference of the circle is OD. And maybe if this line was, even if this OE line was if it was a bit larger, then we know it would be subtended by that arc. Or even if we had a line over here that extended all the way to the circumference, we would know that it was subtended by this arc. And that's not the case. So angle at center twice as much as angle circumference would also not be applicable. Now, the long awaiting theorem that we want to see is applicable to this question. Line from center to midpoint of chord. Now, what does this theorem entail? It tells us that the line from the center, and we're not referring to a radius, this is just an ordinary line from center that touches a chord. However, that chord already needs to have already been split into two equal parts, or that chord needed to have already had a 90-degree angle right at the point where that line touches it. So yeah, now we have to look for, we need to look for something similar to this in the diagram. Now let's start with OE. OE is a line that stems from the center, and DF is a chord. We have to understand what a chord is. A chord is a line that divides the circle into different segments. So for instance, this would be an example of a segment. It is just a space that the chord carves out of the circle. Okay, it carves it out of the circle. That is a segment. That's a chord. Now, DF is a clear example of a chord. Now we have OE. OE stems from the center of the circle. It touches that chord, and the chord that it touches is already made up of two equal lines. DE is equal to EF. So we definitely know that line from center to midpoint of chord is applicable to this question, meaning that the angle between the DF line and OE will be equal to 90 degrees. Now let's look at OG. OG is a line that stems from the center and touches the chord. Now, this chord wasn't is not split into two equal parts, but there is a 90-degree angle between the OG line and the chord, meaning the OG line is perpendicular to the chord, which further validates the fact that we can, validate our answer using the midpoint theorem. It further validates the midpoint, not the midpoint theorem, sorry, line from center to midpoint of chord. We have a line from the center and it touches G is the midpoint of the chord. Why is that? Because there's a 90-degree angle right next to G. And what does that imply? That implies that OG splits HF into two equal parts. So HG equals to GF. So now those are all of the theorems that are quite visible in this question. Let's continue on. Determine given reasons the length of OD. Now, OD is clearly, it is undeniably clear that OD is a part of a 90-degree triangle. And we can, it is also very visible that this 90-degree triangle already has sides that have values, no numerical values. We know that D equals to 12, we know that E equals to 5. So all we have to do is we just have to use Pythagoras to calculate the value of OD. Okay, and before you start with that, you do need to state that OED, which is this angle over here, equals to 90 degrees because of center circle midpoint chord. You can just say line from center to midpoint of chord. Line from center to midpoint of chord. So just write that down. Line from center to midpoint of chord. So you're just going to use Pythagoras since OD is the hypotenuse. It is the line that is right opposite the 90-degree angle. It is the line that is the longest side of the triangle. Take OD, take it to the power of 2, then take the other sides, 12 to the power of 2, 5 to the power of 2, add them, square root it, giving an answer of 13. So we know OD is equal to 13. And then for the next question, determine given reasons the length of GH. GH. Now, you're going to have to apply a bit of knowledge, but it's very easy. Now, we can clearly see that GH is a part of a longer line, HF. And HF is a line that is split into two equal parts. HF's length is 25 units. And we know that HF is split into two equal parts. So that means if we take 25 and we divide it by 2, we're going to get an answer of 12,5. Okay? So that means HG will equal to 12,5 and GF is equal to 12,5. We have to apply logic. Okay, there's no other way to explain this. It's very simple, guys. HF is a line. It's a long line. We know what the length is, and we know that this HF line has been split into two equal parts. So if you want to calculate the value of the two equal parts that it is comprised of, you have to take the length of that line and divide it by 2, giving us 12,5. So we know that then GF or FG is going to equal to 12,5, but you still have to validate your reason. You have to say that line from center to midpoint of chord. Line from center to midpoint of chord, because OG splits HF into two equal parts, allowing us to conclude that 12 FG equals to 12,5. Okay, everyone, hopefully this video was helpful. Do make sure that you check out a few of the other videos that we've posted previously if you've missed that. It's going to be incredibly helpful towards your understanding of Euclidean geometry. I do strongly suggest that you binge watch the videos as your exams are very close by. They're literally around the corner. And also, we have sessions every single day, daily sessions, in order to get you from having a very low mark. Even if you've been failing and struggling with math throughout the year, we can get you to improve your mark by a large percentage. Okay, and we do this with our comedy arts exam question file, where we have numerous amounts of questions, literally dating back to 2015, where we go through the questions that have a very high chance of being in your exam. So if you'd like to join, consider sending an email, or you can leave a comment down below. But other than that, we will see you in the next video.